This video discusses slope and y-intercept and how we can use slope and y-intercept to help us graph equations. You might hear my dog every once in a while make a noise. That's what that just was. What slope is it represents the steepness of a line. And we talked about yesterday when we did our Desmos activity that the slope of a line could be positive, negative, undefined, which is a vertical line, or a slope of 0, which is that horizontal line. The posters in my room also remind you of slope, but let's just cover it here again. Slope, if we're looking at a graph, is the rise between 2 points divided by the run. Some people like to think of it as the m in the equation y equals mx plus b. And some people like to use the equation y2 minus y1 divided by x2 minus x1 in this case. So anytime we look at slope, if we mention the slope and we think of rise over run, the m in the equation, or this actual equation using 2 points, we can find the slope. Also remember that slope and rate of change are exactly the same thing. We can use those interchangeably. Now let's look at y-intercept. So the y-intercept is where the graph or the line crosses the y-axis. And anytime we're referencing a place where that is actually on a line, we want to name it by a point. I just wrote y-intercept, not y-axis. It's hard to talk in. There we go. The line crosses the y-axis. And I'm going to put at a point. So no matter what we write, we need to make sure that our final answer, when we say our y-intercept is this, we would write it as 0, comma, whatever that y value is in this case. We also know that our y-intercept is our b value in the equation y equals mx plus b in this case. Y-intercepts are usually figured out when we're just looking at the equation, which we'll do in just a few minutes. But just a reminder that our y-intercept could also be something like our initial value or what we start with. For instance, if we had a y-intercept of 1 and we were talking about how many cakes we were going to bake that day, if our y-intercept was 0, 1, that would imply that we would already have 1 cake made. All right, let's look at our 2 examples, keeping in mind the things we just wrote above. And I'm going to show you a few different ways to figure out the slope and y-intercept that might be handy to you. You can use either way as you go through these problems. So let's look at the first one. We notice that our equation is right here, and our slope is 3/5, and our y-intercept is a 2, because if I were to match up y equals mx plus b, we could just match up each piece. Our m is 3/5, our b is 2 in this case. So for our slope, to figure that out, to graph it, I'm going to show you how to do it from a table first. So whenever we graph slope from a table, we're basically picking some points that we can plot to represent that slope. So I always like to pick some negative points and some positive ones. The reason why I'm choosing -5 is because I want it to end up canceling with that 5 in the denominator. So when I substitute a -5 in for x, I would have 3/5 of -5 plus 2. Now, 3/5 of -5 is going to give me -3. -3 plus 2 is going to give me -1. So I know one of my points is -5, -1. My next point, I'm going to substitute a 0 in for x. So I have 3/5 times 0 plus 2. We know 3/5 times 0 is 0 plus 2 gives us a 2. So here our point is 0, 2. Now, just to check to make sure I'm doing this right, if I were to do rise over run here, I should get 3/5. Here I'm going up 3 and right 5. I know I'm right. And again, that's my dog that you're hearing in the background. All right, and then our last one, we've got 3/5 times 5 plus 2. 3/5 times 5 gives us 3, plus the 2 will give us 5. So now I'm going to graph the point 5, 5. Right there. From here, I'm going to draw, I'll pick blue, I'm going to draw a line connecting the points that I do have, like so. We always want to draw arrows at the end of our line because that implies it goes on forever, and they actually do. And if we look, we actually took care of our y-intercept right away with that. We knew our y-intercept was right here with that 2. We would always represent it as a point of 0, 2. And I see that that was plotted through our points right here. Look, we've got 0, 2 right there. So that's one way to graph a line using slope from a table. Now we're going to move to our second example where we're going to look at graphing slope just in a little different way. Some people prefer this way over the other one. Some people like to pick points and plot it as well. So here, if I write my slope-intercept equation above my problem, I have y equals mx plus b. And I immediately notice that I see a negative sign in front of the x. So if I were to rewrite this equation, it would be y equals negative 1x minus 4. So in this case, our slope, we know, is negative 1, or we could write as negative 1 over 1 in that case. My y-intercept, when I look at that, is negative 4, but I always want to write that as a point, as 0, negative 4. Okay? So an easy way to start this when you have these two pieces of information is you start by plotting your y-intercept, which we know is 0, negative 4. So 0, negative 4 right here. Now my slope is negative 1 or negative 1 over 1. So since we know slope is rise divided by run, I'm going to rise negative 1, which means I go down 1 unit, and I'm going to run 1. So that's my new point. I'm going to follow that same pattern a few times. Rise negative 1, run 1. I've run off my graph now, but I can do the same exact process in reverse. So I've got rise over run. Now, basically, my slope is this. When I'm going backwards, instead of going down 1, right 1, I'm going up 1, left 1. So keep in mind that 1 divided by negative 1 and negative 1 divided by 1 are exactly the same thing. So let's follow that pattern to get a few more points. It basically looks like you're making that staircase. You might remember this from 8th grade when you made like slope triangles. From there, I'm going to connect my points in a line like so, a nice straight line. Make sure I add my arrows, and I've graphed that line as well. So again, two different ways to look at slope and y-intercept. The first example that we did on the left side, we picked out some points that we wanted to graph from. We confirmed that we were correct with the slope by drawing a quick slope triangle, 3/5. I'm looking, my 3/5 is positive and my line is positive. We also noticed that our y-intercept was 2, but we wrote that as 0, 2 since it's a point, and we found that in our table as well. The second example, all we did was pull the slope from the equation, which we saw was negative 1, and we rewrote that in rise over run form, negative 1 over 1. We also noticed our y-intercept was negative 4, so we wrote that as 0, negative 4. We started to graph at the point 0, negative 4, and then to finish out our problem, we used our slope to find more points. Our slope was negative 1 over 1, so we went down 1, right 1, that was a new point. Down 1, right 1, that was a new point. We did the same pattern in reverse. Up 1, left 1, up 1, left 1 to get those points. Either way you do this is fine. They'll work for any problem. I guess it's just a preference. Maybe you could bounce back and forth between the two methods as you continue with your work session.